So once again, welcome to our first course on machine learning fundamentals. My name is Andrzej Wodecki, and I started my IT career more than 20 years ago with implementation of large enterprise systems, ERP systems like Oracle and SAP. Later on, I made some technological startups. Some of them are still alive, some of them are dead. It was a great chance for me to test myself as an entrepreneur. In the meantime, I had some experience with e-learning. And for more than 10 years, or approximately 10 years, I'm involved in different AI machine learning projects. And I have two specializations in this area. On one side, I help companies in IT implementations of such systems. So, for example, I configure different data science platforms or implement this in different technology stacks, starting from open to cloud-based like Amazon or Google Vertex. And this is one field. Here at the school, I teach two topics. Machine learning fundamentals, and later on, if you choose it, also architectures of AI systems, where I mostly focus on machine learning deployment and the managing a machine learning model during its life cycle using ML DevOps methodologies. So this is the one part of my specialization, but the other part is helping companies in business cases. So I work mostly with mid-sized and large companies to firstly identify the best possible business case for AI application. And on the other hand, I made research in that area at Warsaw University of Technology, where I also work as a scientist in the Department of Management, where I study simply how to make money on those projects. So this is a brief introduction of myself. Obviously, we'll get know each other a bit better during this workshop. So the goal for today is to initiate our lectures. We're going to have 15 lectures together. They will be they will run in parallel with your labs. So today I'll just simply introduce you to the topic, introduce you to the course structure, to communication rules and all that stuff. So let me start. Obviously, you have all my course materials at the moment already uploaded into Microsoft Teams. So let's start with PowerPoint presentation. So machine learning fundamentals. So fundamentals is the first keyword. So we're not going into the technical details of, for example, machine learning deployment or how different algorithms work. We're going to talk about how to teach machines. Machines learn by themselves, but we also, as humans, are for making this learning a bit better. So that's the goal of data scientist, main goal of the data scientist. So, but before we dive into the topic itself, I will start with some inspirations. My personal inspirations. Obviously, if you look at the history of AI, artificial intelligence, you may write huge books only on this topic. But so I'll just simply share with you my personal insight, my personal aha moments in my life. So the first such aha moment was, I would say, 7 years ago, when I realized, and it was mid to 15, where at that time algorithms became better than humans in image recognition, in recognizing objects on pictures. And as you can see on these pictures, that may be a question of life or death for Chihuahua, which misled with muffin, and tragically, or for example, for me, when I simply do not recognize my wife on the street. So machine became better and at image recognition to 15 many years ago. Next came the area of devices which can not only understand what you are talking to them, but also are capable to doing simple tasks. Like, for example, this device, which is Amazon Echo, with Amazon Alexa as AI behind us. By the way, it's significantly developed also in Poland by a Polish team from Gdańsk. I can go to my kitchen with this device on the table and I can ask, okay, Alexa, play me some music, and she will play. She or he or it, I don't know the gender of Alexa. So machines can understand. They can do some things for you, some simple or even more advanced tasks, or just simply can talk to conversation, may have conversations with such a device. Nice. Next step, autonomous devices. Autonomous devices, plenty of them around us. We even do not recognize them. In Warsaw, we have autonomous shops, Żabka Nano, where you just simply enter to the machine and do everything autonomously. This is autonomous, no human inside. Or something like this, which is a car. Besides this one is of Waymo. Waymo is a brand of Alphabet, Google, as you wish. And for me personally, this is a very important project because it combines both technological and social aspects. When you look at this project from the technological perspective, it's a combination of very, very advanced sensor-based technologies. So you need to acquire a lot of data from different sensors. You need to aggregate them, sync them using, for example, sensor fusion technologies in order to have so-called situational awareness. And you need to do this in real time because of the safety, security, yes. But on the other side, this is also a social project because we as humans have very low tolerance of machine errors. So, for example, you very, very well remember when, for example, 3 years ago, the autonomous car driven by the Uber driver killed women on the highway. But we do not, many cases, want to remember that it was 2 a.m., just so it was middle of the night. She was just simply passing with her car, probably drunk, in a place where it's not allowed to, but we remember that, okay, autonomous car killed the woman. So in order to have something like that, have such technologies around us, that requires also a lot of different regulations and human understanding. So very interesting. Very interesting project, extremely advanced, obviously. So another example, I became the artist in 4 minutes a few months ago, just because I knew that I can chat with Midjourney on Discord, and I asked the system, generative system, to paint a gentle woman just for me, because that's original painting. Yes, I did it. I can think about myself as a creator. In few clicks, I generated the picture. I do not know whether you like it. I like it, yes. For me, she's really subtle. Wow. I was really impressed by the capabilities of image generation systems. So what introduces us to a completely new, extremely dynamic field of generative technologies. The next step may be this one. So this is 2D to 3D systems, where as input you have a two-dimensional picture, as an output you have a three-dimensional object. And this is learn from one look technology. Obviously, there are some other technologies, which, by the way, may be not only used for fun, but for people who live from producing three-dimensional objects out of two-dimensional images, may really improve efficiency of their work. Okay, collaborate at the moment with one of such companies. But still, this is just one step from here to something like this. This is text to video. So you can use, for example, Imagen from Google or Phenaki from Google, different projects, where as a prompt you say, for example, generate a video with teddy bear washing dishes, and it's here, as you can see. I like it very much. I don't know whether you like it. Imagine that you can ask the system to generate a video of your favorite politician washing dishes. Wow, that would be something. And this is very interesting. I don't know whether you have a time, let's say 2 minutes to see video. Would you like to see a short video? But it's 2 minutes. How do you think?
Why not?
Why not? So let's try. Okay, we are just simply warming up, so let's treat it as a part of the soft intro to the topic. That was something for me, really. I'll show it to you. Well, a lot of different videos like this one, but let's look at this. No sound. Let's watch it for 2 minutes. Something. Before we continue, that may be inspiring to you. And there is a very interesting project called AlphaCode from DeepMind. This is research, and what they did. This is scientific research. You have on the left-hand side the task from the competition for programmers. So in the natural language, we have the description of the problem. As you can see, just generate some algorithm which solves some problem. Yes. So this is natural language. If you attended such competitions, you know how it works. Like you have such a description, and now your task is to firstly generate a pseudocode and then implement it in a given language. So what it does, you can test, for example, pass. Let's say that's this one. I like Python, so I can play. It works like this. Can you see? So it reads the problem on the left, generates the pseudocode on the fly as an intelligent algorithm which solves this problem on the left, yes? And in real time, it creates the implementation in the language like C++ or Python. Okay, so it's a bit more than just extension. Yes, it's not just a snippet extension. So that's something, by the way. Just have a look at this AlphaCode. Very, very inspiring. At the moment, they are at the level of the median of those who attend such competitions. So that means that's valuable. Okay, so let me continue with this. Okay, because we are running out of time. Later, the next step, I promised you some next steps after this. So I took this credit risk assessment case, and I asked the system, GPT-3, to generate a context diagram of an artificial intelligence-backed credit risk assessment system in the bank. For you to know, there is a 4C methodology, 4C, CCCC, yes? A methodology of drawing architectures of IT systems. The context diagram is the top level, highest level of generalization. The screen here is adopted by me because as a kind of the prompt for the ChatGPT, I said, okay, I'm a business architect or IT architect in some bank. I consider doing such a system. And I asked, okay, please give me a high-level diagram in mermaid language. Mermaid language is a textual, it's a text, yes, it's a language. So in text, you create a set of instructions which later on may be used for rendering of diagrams. And what I did, you can see that this is the rendered diagram. So that was the answer of ChatGPT was the full documentation of the first level, saying, okay, you will have such roles, such actors, they will do such things, and all the description supplemented with this diagram. The next step, I went a bit deeper. So the next C is the container diagram. So I asked the system to draw me for this service a container diagram. And if you look at this carefully, it's not that stupid, by the way, because it has identified on the infrastructure layer, load balancer, engine cluster, data repository cluster. Then you have the bank infrastructure of external data repositories. And as you can see, there's an application server, there's a web server, user, data rep, CRM, whatever. And you have relations like communicates with or store data in. So let's drill down. Next step, I was really impressed. I asked to draw the AI engine container diagram and its sub-functionalities. I got something like this, which is, by the way, close to my profession, which is, as I told you already, I work for as an ML DevOps engineer sometimes. And now this structure is quite good. It's not that perfect, but it's quite good. How do you think how it may impact your life?
Less system architects.
Mhm.
I mean, those are tools that are supposed, for now, they are supposed to simplify our work.
Yep.
Right. And for now, it's as it is mostly done now, it's how to say this, while it generates good stuff, it still requires someone to have an
Supervision, yeah.
oversight. Yeah, supervision. Sure, as it is right now, what it might do is you don't need as many system architects. You'd need, for example, one team of system architects, if you would make a team of system architects that would see and implement changes instead of building something from
Yeah.
scratch. The problem is it might kill creativity, right? There is a debate. I'd say some people are like, you never programmed in COBOL or C, your first languages, you're not a real programmer. And this might apply here because we might have and some time now, I don't know and how much time, there might be a generation of people that do not learn to build system architecture from scratch. There might be people that start with this and learn how to improve it, right? The technology goes forward and it's unpredictable what might happen. Right now, it might simplify our work. In some time, it can eliminate system architects, maybe. We don't know how it will go, but it creates a big unknown. So I'd say one thing it might do is, even if the implications are unknown, it might destabilize the job market, for example.
Mm-hmm.
I mean, this is one of my biggest concerns, is getting a job in IT, of course, but there is a lot of implications it might do, but maybe I'll let other people talk as well.
Okay. I think that we'll touch this slightly later on, but what I would like to point now is that, okay, when I started using GitHub Copilot, I was afraid that the code it generates will be wrong, yes, because it may make mistakes. I think that after, let's say, 5 years from now, it will be as perfect as libraries I use, like Pandas or NumPy are. I, at the moment, do not cross-check the quality of the code of the community built libraries like scikit-learn, whatever, as you probably also do not check the quality of the code which is behind Excel, which you use for the computations, yes? So maybe we will have to go up a layer up, yes? Just still trusting all those layers which are at the bottom. Yes, that's a question of time. Okay, but let's continue. Let's continue because I will come back to this in, let's say, 15 minutes from now. This is the next very interesting application. As you can see, this is just a simple plugin, probably powered by GPT-3 to one of the task managers, which does what? It decomposes the task, yes? Breaks task down. Yep. How do you think, who may benefit out of those solutions like this one? How it may help in your daily life?
Oh, it's a project management site, I believe.
Yeah, yep. Look,
so
you
the
just
project
simply
management.
Yes, you can do also the same with ChatGPT-3. You can ask, for example, ChatGPT-3. That's a question of prompting, you know, by the way. If you have some spare time, there's a very, very, very dynamic area, which I'm a big fan of at the moment, so-called prompt engineering, which is just the art of, let's say, the science behind how to ask question to generative model, whether it's a text model like GPT-3 or to images model, okay? The way how you ask strongly influence the answer. So this is so-called, once again, if you have some pen and paper, write it down, prompt engineering. But coming back, you know those, if you work, I guess some of you works already, you'll spend dozens of hours a week on meetings, sprint meetings, etc., where you essentially do three things. When you plan, you'll need to make a product breakdown structure, so decompose your final product into sub-products, sub-products, so make a kind of the product tree, yes, and after that follows work breakdown structure where you decompose tasks like here, and then you monitor the progress. So instead of spending hours, you just simply ask the computer to do it for you, and you have once again the same pros and cons as previously. You just simply simplify work and make it faster, but on the other hand, I found this common work where we work together on a product breakdown structure mostly as a way of understanding what are we going to deliver. Yeah, so this is main goal for me, because in many cases when you start the project, everyone has a different vision of the final goal, but if we break it down, we have a better understanding. So once again, we can ask the computer to do this, but the pitfall is that we will miss this common understanding on the final product. But still, we have this at hand. This is a tool. As always with a tool, we cannot say that the tool itself is wrong. Yes, it's bad or good. This is the way how we use the tool and for what makes this tool good or bad. So let's continue. This is quite interesting example I'll show it to you. I intentionally did it in Polish, so let's listen.
Architektury Kubernetes doceniane są za wysoką wydajność konteneryzowanego oprogramowania oraz możliwość kontroli kosztów. Umożliwiają one również migrację aplikacji do chmury prywatnej lub publicznej. Wirtualizacji podlega tylko system operacyjny, pamięć RAM oraz system plików. Kontenery zużywają zatem mniej zasobów procesora i pamięci. Niezwykle istotną cechą Kubernetes.
Okay, so as you imagine, in the context of our lecture, it's not that difficult. I used a movie generation system to generate this avatar for me. It works like that you just simply copy paste some text, and then you choose the avatar. Yes, this is the text. Yes, you choose the avatar. You have plenty of different avatars. You choose the voice. You have plenty of different voices. You choose the language. You have almost all the languages. You can ask the system to choose images and videos for you as a background, or just simply dynamically adopt the content. And it creates the video for you. It generates it. Obviously, it's a paid service. It's approximately $2 per minute because it consumes a lot of computing power, mostly GPUs. And later on, what I can do, I can, with one click, translate this video to another language with the same quality. And coming back to your dreams, there are some other systems like this. This first one is Synthesis.io. If you would like the best, probably the best, but also very expensive, is Synthesia. It works the same. You can generate the commercial video using really good quality avatars who just simply, it requires really attention to recognize that it's AI for commercials, as you mentioned previously. Yes. So this is very interesting. And once again, if you just simply look at this, they have in their interface integration use with GPT-3. So what I can do as a teacher for you is the following. I can, oh look, GPT-3 is on my top left, so that's, I almost do not use Google at the moment. I can ask GPT-3 for suggest course structure or machine learning fundamentals lecture. You can ask this. Okay. Yep. As you can see, I can ask. Next, I can ask the system to explain, for example, feed-forward neural networks, or directly in this interface, I can put the text in using GPT-3 and generate beautiful videos for you. So as you can see, it's not the only for students, but also for teachers. Obviously, I'm joking. I do not do this that way, but believe me, when I tested the solutions, it was really temptative to instead of recording, just simply put some text in. So that's next step. But okay, awesome. It was high level. But the question is, will it really help me in my professional life? Okay, we need to come back, just touch the ground, come back to our companies, the companies you work for at the moment, or you're going to work in the future. So my course won't be on this high level tools. It was just for inspiration. We just simply hit the ground. And during this course, I will start. The structure of the course is very uncommon. You will see it later on, because I decided to start with the examples of using machine learning in different contexts, in different companies. Okay, so I start with examples just to give you the feeling of the capabilities which trained machines can have. Okay, so we have machine learning, so we need to teach machine. Okay, so we start with those skills which are taught, and you will see that generally you can classify those skills into capabilities of solving three types of problems. Two of them are prediction problems. This is the classification and forecasting, and the second one are just the insight into the data, pattern identification, which is the segmentation. So first, we will start with classification, which is the problem of the prediction of the categorical variable. Okay, so the variable we are going to predict is a category, so it's not a number. We'll start with examples like how to predict where the customer which comes to you is a new customer. Okay, you have just know some basic features of the customer, and the question is whether this customer will bring you a lot of money or not enough money, or just simply small amount of money, high low revenue. And next I will show you how to train the model which will predict whether the customer will churn, that means leave to the competitor or cancel the subscription. Next, for segmentation, I will show you how you can segment your customers using recurrency monetary frequency method, which is one of the most common methods for segmentation. Next, how we can use this segmentation to make some decisions about the future marketing campaigns. Once again, it's a business case. Next, for forecasting, prediction, this is so-called regression problem, where we predict the numerical variable, not category, but a number, which is a completely different animal. I will show you how you can use this tool for predicting the stock prices, demand for products, etc. So we'll start with the examples. Next, we will talk about how can we train, okay, because you had those skills, but the question is how to train those models. We are teachers as data scientists, we are teachers, okay? We have some models which at the very beginning of the training are stupid and we want to make them wiser. So this is the next part of my lecture. I will show you, and you will see this directly from my first part of the lecture, how we can make the inference with the trained model. Generally speaking, this is the question which you pass to your magic ball, which is a kind of, I don't know, we call it model, but it may be a neural network, or serialized pickle file, for example, I don't know, support vector machine model for classification, whatever, logistic regression classification, whatever, and it generates the answer for you. So you'll experience this during the first part of the lecture, but later on I'll show you how we can train the model. This inference stage is what we as final users in most cases experience, okay? So even if you are the media consumer in Netflix, okay, you consume the model in the form of the movies recommended to you. If you are a business analyst who wants to predict the demand for your product next month in a given store, you use this model. This is the inference. But in order to have something like that on production, we need to generate the model. So we will just simply learn how to train the model. So having some data as input, how to identify different algorithms which will extract those patterns out of this data, and then choose the best model and make it on production, deploy it into production. And before we continue, do you have any questions till now, or it's clear? I can't see your faces, so please, if you have any questions, just please interrupt me, okay? Is it clear? This project within the company. It's not for the startup, okay? It's most typical case for me, so whenever I'm invited, because I work as a freelancer, okay, or I have some other friends which I collaborate with, in most cases, mid or large size company invites us to create a kind of the machine learning solution for them. This is the most typical scenario, okay, flow. Everything starts with the raw data. Firstly, obviously we are going to have a separate lecture on this, so don't worry, just a high-level overview just to show you where we are going to focus in this lecture. But first, in the first stage, we need to define the business problem. So I speak to business. I ask them for what are expectations. Why are you doing this? What benefits do you expect? Okay, etc., etc. And then I translate this to my machine learning problem, whether it's a classification, regression, segmentation, yes, mostly. And then I say, okay, I can train the model for you, but you need to provide me with data. So everything starts with raw data, okay? And the problem here is that this data needs to be extracted, and this is the first stage. Sometimes it's quite easy, but in most cases it's really difficult. Firstly, because you may have many different sources of this raw data. If you're lucky, and if your company has integrated system like ERP system, enterprise resource planning system like SAP or Oracle, or it has a good quality data warehouse implemented, that you are really lucky. But sometimes you may have a lot of different legacy systems. One is for customer relationship management, another is for production. Another are some external systems like your social media channels. Some other are Google Analytics for your Google Ads, whatever, yes? In that case, data extraction becomes a real challenge, because first you have this data in different places. Next, you have this data in different formats. They may be structured or unstructured, yes? Next, you may have a batch data, which are quite stable, stored somewhere in databases, or streaming data. Yes, so depending on whether you are going to ingest the streaming data or connect to the stable sources, you're going to use completely different tools, techniques, and methods for data extraction. Yes. Next problem, which is important at that stage, is that you need to have someone on board, a data engineer, so-called, who knows where the data is, okay? Which data is where. So in many cases that requires quite good data governance level, which is not that obvious in the companies, yes? And this person needs also rights to access this data. Okay, there are many limitations due to the internal data safety rules, yes, security rules, or GPRD. Okay, personal data protection rules. Yes, there are many different obstacles here to have this data on board. So, but imagine that you have this data. The next step is data analysis. And in data analysis, you try to understand data, and there are technical aspects, like, for example, for identification of different correlations, distributions, for categorical, numerical variable, okay, identifying the empty null values or some other numbers, data quality checks, etc. But on the other hand, and this is in many cases very time consuming, is just to understand the features. If you work for the business unit which is responsible for sales, for example, they have a lot of different crazy definitions, concepts, which as a normal human being won't understand. The same for manufacturing, yes, or for supply chain management. They have their own features, ideas, concepts, which really takes time to understand. So this is data analysis. Okay, and after that, if you have this data analyzed and you understand the business, you have once again generated the business case for a problem, for a project. You need to prepare this data for modeling. If it's a classification, you may have different algorithms. In many cases, those algorithms require data in given formats. So in this data preparation stage, you clean the data, you enrich the data using, for example, external or internal data sources. You transform the data, you generate new features. It's a feature engineering, huge area of research, just to prepare the data for modeling. Any questions, comments for that stage? Okay, if not, let's continue. Okay, next step is just model training. Having data prepared, you train dozens of different algorithms, and even for the same algorithm, you may have many different so-called hyperparameters, which are simply knobs of the model, okay? You just set those knobs in different configurations and you receive the models of different quality. Next, you evaluate those models, and that means that you compare the quality of those models and compare them according to some quality measure, depending whether it's a regression, classification, or segmentation problem. You will have different quality measures and choose the best model, yes, out of those 100. And then you validate this model on a separate data set, which is not included in those iterations. Yes, this is very key, just to take a part of your training, whole training data set completely apart. We're going to have a separate lecture just only on this, on the model validation. So once again, I train dozens of different models here. I choose the best model thanks to evaluation, and then I test this best model on the data which was not seen during the training stage, and then I have the overview of the quality of the model, yes? And sometimes model validation also means giving this model to your business users to check whether they like it or not, because as data scientists, you have completely different vision of the quality of the model than the business users. So they test, for example, the model for so-called edge cases, which are just simply strange, stupid questions, and testing whether the model will cope with that or not. So this is the model validation stage. Any questions? Okay. If not, let's continue. You have the trained model, you put it into the model registry, and then you deploy it to prediction service. So you put it in production. This is so-called deployment. And then here on this arrow, we have so-called serving. So it's just simply taking care about answering all those requests which come to your system. You may serve it on different channels. Yes, it may be a fast API, that may be a web app, that may be a mobile app, whatever you want. And next comes performance monitoring. That means checking whether the quality of the model is kept on the level accepted by you. Okay, And now the question to imagine that you have the business case where you want to create the model which predicts the demand for your goods, like, I don't know, yogurt, okay? So the model will generate for this yogurt the prediction of the sales. Today is a Monday, and we are going to predict what's going to be the sales for Friday for a given location. Now the model has, when it comes out of the lab, it's a perfect quality, like, I don't know, MAPE, that means mean average percentage error, at the level of 5%. What's going to happen with the quality of that model in a week from now, in a month from now, in a quarter from now? What do you expect?
The quality will decrease because it can only use previous data, as old data, so it can't predict in the future.
Life is changing, world is changing, okay? You have new marketing campaigns, you have a competitor, you have new products which may substitute the product. Naturally, it will decrease, yes? So, okay, when you have one model, that's you can control, yes? You may have a data science team which will monitor it by hand. But when you have dozens of thousands of models, yes, which is not that rare. If you create a separate model for each customer, you have millions of models, yes, on the production. Or, for example, if you train each prediction model for each product is not keeping unique, you have thousands of different models. So you need to automate this, yes. So you need to automatically detect so-called model drift or data drift or concept drift. There are many different concepts. And then when it passes some thresholds, yes, which is accepted for you, generate a trigger for retraining, yes? And now, tricky question for you. First question. Imagine that in your project, yes, you have two stages. First stage ends up with the trained model. The second stage ends up with the model deployed to a production and sometimes included this performance monitoring. And you have, let's say, 100% of time. How much do you think the stage with the trained model as a product will consume compared to the deployment and operationalization stage? How do you think? What would be the proportion? Model training to operationalization percentage.
But percentage of what? Could you repeat?
Once again, you have 100% of time to be spent in man days, for example. Yes, man days or man hours, whatever. Yep. And you want to split the budget. The first of the budget comes, first part, and the question is how many percent? Yes, to the model training, which ends up with the trained model. The second one for the operationalization. Apologies for my English. Would you split it 20-80, 80-20, 50-50? How do you think?
Probably the first stage would take longer.
So what would you say? Roughly, numbers, just to test your intuition.
70-30.
70-30. Who else?
Maybe 60 training.
60 training, 40 deployment, yes? Or operationalization.
Like
Good. Okay, so before we continue, the next question. If you have this first stage, yes, which ends up with the model training, forget about the second one. How much time you will spend, the same question, on data extraction, analysis, preparation compared to model training, evaluation, and validation? Once again, percentage. Data prep, how much? How much time?
Data preparation would probably take more man hours because like model evaluation, model training is done just processing time. So you can set it to work during the weekend or whatever.
No, okay, but in model training, you need to also identify the best models, fine-tune them. That's a lot of research, yes? Okay, so, but give me the numbers. I don't know, 80-20, 20-80, 50-50.
I'm going to go with 70-30 again.
70 for data preparation, yes?
Yes.
Okay, so once again, my experience plus what I found in research, yes? So for the last question, it's really 70-30. So data prep, data extraction, analysis, and preparation is around 70. At the moment, I'm in the project for one of the largest European agencies where it's 95%. Depends on the quality of data they have, yes? But this is really time consuming. It's not sexy, but it's really time consuming. So sometimes I compare it to making a sushi, for example. Yes, if you want to prepare good sushi, you need to find the concept and then gather the best food from all the stores, which takes a lot of time. Then put everything on the table, wash it, clean it, cut it. Yes, it takes a lot of time. When you have it well prepared, then the model training is almost automated. Yes. So this is 70-30. It has changed significantly 2 years ago when we had the explosion of so-called AutoML system, automated machine learning systems. We are going to work with such systems in our course. I'll show you some open source, some commercials, but 70-30. But the interesting thing is on the first question. Because due to the research made by Google, and this is the only base I have at the moment, despite my own experiences, the ratio is 95. So 5% for model training, 95 for operationalization. And that was shocking to me. But it really corresponds also to my experience. Can you see? This is a very interesting fact. So it's like in a business model for a startup. The business plan, even if it's greatly thought of, yes, you made a great research on market analysis, this is the document. It's only 5% of the success, 95% to make it work. Yes, so it's good to keep in mind, yes, when you're going to learn or plan your new machine learning project, okay, in many cases people underestimate this stage. This is a very important and quite difficult stage. So that's why, in order to improve this, people had to invest or create different methodologies. One of those methodologies, so-called ML DevOps, this is the extension of DevOps methodology, which is a methodology of sharing the work between developers and the people who are responsible on deployment and maintaining the system on production. Yeah, so this is DevOps. We had to add this machine learning concept, machine learning part. So we have methodologies for this. We have also tools for this, and this is one of my favorite tech stacks for machine learning full stack projects. So as you can see, you have data prep tools. Each logo is either a separate company or the product. So we have data preparation stage, like data exploration, data version control, feature engineering and storage, data labeling, data quality checks. Next, we have a model building, including experiment tracking, model optimization, AutoML tools, yes, model training, whatever. Next, you have production, yes, so this is the first. And you have model deployment. You have model serving, yes, you have model observability, compliance and audit, model validation, etc. The picture is a bit more complicated. This is the landscape created 2 years ago. It's a bit more advanced. I have a bit more labels here. And the interesting thing is that you can look at this, you will see that there are some logos with products which appear in many different places. So you might have a system which is horizontally spread across those different needs. So it does not. Some of them are commercial. Many of them are open source. Some of them are open but supported by developed by commercial companies like MLflow, for example, which is developed by Databricks. This is my favorite landscape. It's quite old. It's 2020. A week ago or so, I have found the same picture, but for 2023. So you have more than 500 different tools for just machine learning and artificial intelligence and big data. Some of them are for infrastructure management, some for analytics and machine learning, some for business application. You have the open source stack here, data sources and APIs. My question to you now, what to do? You are a young person, okay? You have limited, obviously you have a lot of time, you have quite fresh brain, yes? Not poisoned yet. And how do you think, what you should learn having such a huge choice of different tools? What are your impressions?
It's a bit overwhelming.
Yep. Yes, it is. But you know, this is the fact. Yes, now the question is what to do with that.
Definitely not try to write another.
Excuse me?
Definitely not try to write another tool of this sort.
Yeah, so definitely not to try to learn all, yes?
Or to add more. Run from this section.
Come on, this is dynamic picture. Yes, each year it will change. Some of those tools will just simply absorb some other areas, so it will just simply grow. Some will disappear. Yes, for some areas you will have new tools, or you are going to have completely new areas like generative tools. Yes, so it's unavoidable. This picture is not gonna change. It will just simply be more and more complex. The question is what you should learn. Okay, so my reflection, just not to spend too much time on discussion, is the following. Firstly, a given machine learning task or a process may be realized in different ways. Yes, you can do the same, you can get the same result in a different ways. So it's like you have the goal just to climb this mountain, you may have different paths. Next, it may be done using different libraries or different tools like command line interface, Jupyter Notebook, IDE, data science platform, whatever. So just to having this analogy, you may achieve this goal, climb this mountain, either using a parachute or the car or motorbike or bike or by foot, by walk or by running. You have many different options at hand, yes? And you may do it in different environments. You can do it locally, on cloud servers, on cloud serverless, by the way, very important now, or mobiles, yes? This landscape is rapidly changing. So the question is, what should I know then? So my advice is the following. It's much more important to know what to do in a given situation rather than how to do it. Yes. So firstly, how to decompose the product, my process. This is my advice. Next, when you choose a tool, stick to the most popular growing libraries. So if you would like to learn something new and you would like to invest precious time into learning some open source libraries, my suggestion is just to check on a GitHub whether it's at the moment developed by a large community. So whatever I choose, I check number of stars, number of contributors, number of commits, and the date of last commit. Okay, so I avoid libraries which were dead, for example, for more than 2 years. Yes, this is very important to me because that means that it's dead. Don't avoid commercial solutions that may be indeed be cheaper, and having not too much time for the discussion on this, I will explain you why it's very temptative to use open source because you don't pay for the license. But at the end of the day, you need to calculate the total cost of ownership, which in case open source solutions includes the salaries of experts. Yes. If you want to do something from scratch using open source solutions, you'll probably have to hire experienced programmer, which costs a lot of money. Yes, so sometimes it may be much cheaper to choose, for example, the platform like paid one, yes, like Google or Amazon or Microsoft or some other data science platform. But, and this is my way, this is my path. Yep. Build your foundations with open source. I learned a lot. Whenever I approach something new, I start with open source. Even it's requires a lot of effort. I remember when I was doing my personal projects on Kubernetes, installing it and running and keeping care about this on bare metal is really difficult. Yes, it's really difficult. It's harder, but gives you a sense of what's going on under the hood. Yep. This is the most typical. I'm just simply slowly approaching the end of the today's lecture, so don't worry. But this modern data scientist skill set requires from a data scientist a knowledge of math and stats like machine learning, statistical modeling, experiment design, Bayesian inference, supervised learning, unsupervised learning, optimization, all that stuff. Next, programming, mostly in Python at the moment. R is a bit less popular nowadays in production. Database, SQL, not SQL. Big data like Hadoop, all those XaaS like Amazon, cloud computing, etc. Next, we have domain knowledge skills like business skills or curiosity about data, hacker minds and problem solving, and communication skills. Yes, you must be capable to explain your difficult concepts, not in statistical terms, but plain English to the business owner. Yes, you must have a storytelling, visualization skills. So it's very difficult to find such people on the market. So we have decreasing supply, increasing demand for such people. This is the problem. The potential is huge, so don't worry, you won't lose your job for sure, especially when you look at the level of the mathematics and the STEM, science, technology, engineering and math at the primary and secondary school is terrific in Poland at the moment. That's my personal experience. So don't worry. So that's why people decided to decrease the level of entry to the industry. They created so-called data science platforms. As you can see, data science platform is a software where you can deliver the high-quality machine learning product, because that's not only training, there's also deployment and ML DevOps, without programming and without advanced statistics knowledge. As you can see, Microsoft has its own, Google has its own, Amazon has its own. There are some dedicated solutions like RapidMiner, H2O, and DataIQ, DataRobot. We are going to use DataIQ, which is one of the best. I have it installed on our servers, but once again, the course is not on the tool, but on concepts. So that's why, although I can speak Python, I decided to show you the most important concepts of machine learning using the quite easy system like DataIQ. Yes, why? Because we are going to touch quite difficult concepts. So we need to decrease any other traction, like problems with the Python, whatever, yes, to the minimum. So that's why I'm going to use DataIQ. I know that on your labs you may have some other, like Dr. Kaviak likes Microsoft. That's okay. It's like a car. Okay, it's the most important is to know where to drive and how to drive. The vehicle you choose needs to cope with your skills. Yes. At the end of the day, in the production, you're going to land probably with the Python with some services from Google, Microsoft, Amazon Web Services, but we are going to use something simple. So that's this. I don't know, we do not have too much time, so this is the list of the things which are the learning objectives, but I would like to focus what this course is not about. This course is not about machine learning algorithms, so I'm not gonna go into details of regression, support vector machines, exhibits, or deep neural networks. Okay, I'll just simply mention them, but I won't go into details how do they work. We wouldn't have simply time for this. Yes, it's not gonna be the course on specific tools. You won't learn here Python, for example. DataIQ is just for illustration, and it's not the course on making money on AI. Although I will show you many different examples of using machine learning in industry. Okay, you have next a set of different knowledge resources recommended by me. So you have this PowerPoint on your Teams. By the way, if you would like to learn machine learning in Python, DataQuest is my personal choice. So that's why I simply put those pictures, which are, by the way, linkable. So I have the hyperlinks there in the order I recommended to you. You have also some blogs and websites. Medium.com is my homepage. This is the best, definitely the best site with knowledge resources I ever met. So this is, if I wanted you to know only one hyperlink from this lecture, that would be medium.com. Next, course organization. The final project will be the project delivered during your labs. You are going to choose in groups some problem, describe this problem, describe the rationale and motivation for a problem, then collect the data, assess the quality, make the exploratory data analysis, then propose the solution like model training, discuss results and model evaluation, and make some reflections. There will be no exam. The mark for exam will be based on the lab assignments. We are going to have practical classes. Course materials are already on the Teams, and I will show you those course materials. Look, they have quite specific order because I start with machine learning applications. Can you see? So as I said, I will just show you regression examples, yes, classification examples, segmentations next, and we'll probably start the next lecture with data types and visualization. This is the key concept. Next, having those examples explained, I will just simply cover the basics of machine learning, and we'll come back to data science process. And we are going to go through this algorithm to business framework assignment. Next, we are going to have I understand. And this is my mistake, so I'll have to delete those. Yeah. Yes. Next, we are going into details of machine learning algorithms. That was a slight change I made a week ago. So here we're going to learn about supervised learning, unsupervised learning, reinforcement learning, and different algorithms, but on the very, very high level, regression segmentation. Okay. Next, we are going to cover topics like model testing, evaluation, and fine-tuning. So we're going to talk about how to evaluate models for classification and regression, and we're going to have a separate presentation on the business perspective of model evaluation. So I'll show you how to translate the statistics. I have only 2 minutes now left. When you look at this order, usually if we would like to follow the data science process, I would have to start with exploratory data analysis, next go to machine learning algorithms, next go to applications, and then to model testing and evaluation. But disadvantage of this would be that you wouldn't know, you would understand why are you doing those things, let's say in the mid of the course. So my goal is just to show you those applications at the very beginning, because later on you will have quite a good context for going deep into the under the hood, what's going on under the hood. Okay, those matters. My name is Andrzej Wodecki. This is my email, and I really, firstly, I invite you to contact whenever you have any questions. Yes, don't hesitate to ask me. I love my job. I love the topic. So when you have some personal questions or just simply job-related questions, just don't hesitate to ask me, but please send it by email, okay? I have problems with Microsoft Teams chat. I have generally problems with chat because I need to turn off everything. So I really, really prefer contact by email. So if you can do it, let's contact by email.